Now that we know how to make a matrix, we need to know how to access parts of it. So for example, if we want to see just the one element on the second row and the third column, we'll know how to do it. And it's all based on rows and columns. To see how it's done, we need a sample matrix. This command will make us one. And here it is. As you can see, its dimensions are 3 by 4, meaning that it has 3 rows and 4 columns. And they're numbered from top to bottom. 1, 2, 3. And the columns are numbered too. 1, 2, 3, 4, from left to right. So how do you look at just the element on the second row and the third column? You give the command x, left parenthesis, 2, comma, 3, right parenthesis. The 2 is the row index, and the 3 is the column index. As always, the row comes before the column. Together, the two indices, 2 and 3, in parentheses and separated by commas, tell MATLAB which element you want to see. And it shows it to you. Okay, let's do this same example again, but this time let's do it in MATLAB. Okay, well, let's look at this same example in MATLAB. We said x equal to left bracket 1 colon 4 semicolon 5 colon 8 semicolon 9 colon 12 right bracket. Note how we've used the colon operator to save typing. You know, we could have done it the hard way, which would have been x equals 1, 2, 3, 4, 5, 6, etc. I'm not even going to do that. It's just too much work, but the colon operator works perfectly. Each row of a matrix is simply a vector of numbers, and the colon operator produces a row vector of evenly spaced numbers. So if we want the numbers on a row to be evenly spaced, we can use the colon operator instead of typing them out, and that's what we wanted this time. So we use the colon operator. Okay, to continue with our example, let's specify the third element on the second row as we did before. So we say x, parenthesis now, 2, 3, right parenthesis, and we see the answer is 7. We always, as here we did, give the row index first and the column index second. We can also use this notation in an assignment operator. So let's say we want to call the variable center, and we set it equal to x, 2, 3, as we did before. Center now has the value 7. Or Bob, I don't know, x, 3, 3. There we go, Bob is 11. And as you can see up here, where x was displayed, this 3 by 4 matrix, on the third row, and here's the 3 down here, in the third column, and here's the second 3, we find the 11. And we can assign a new value to a specified element, x, 2, 3, instead of being 7, I'd like it to be 97. So we set it to 97. You'll notice that while we only mentioned to MATLAB one element, it shows us the whole matrix. Well, we will notice, however, that it did make the change we requested. So element 2, 3, that is second row, third column, is now 97. And if we wanted the second row, second column to be, I don't know, 123. If we look at it now, it's 123. So what happens if we assign a value to an element of a matrix, but the matrix doesn't exist? Let's say, for example, a matrix XYZ. If we look over here in the workspace, we'll see there's no XYZ matrix, so it doesn't exist yet. Another way to check to see if it exists is to try to look at it. We get one of those awful red messages saying we made some kind of error. Okay, MATLAB, I did this on purpose. It's not really an error this time. But anyway, let's set a value to it. X, Y, Z, element 2, 2, is equal to 123. So we're doing the same thing we did with X, but now we're doing it with a non-existent matrix. So you expect some more red to come back, I'm sure. Well, surprise. What is this? XYZ equals 0, 0, 0, 1, 2, 3. Well, here's what MATLAB did. Said you want to have a matrix XYZ and you want to have 123 on row 2, column 2. I'll give that to you. You didn't tell me what goes on the rest of the rows and columns, so I'll put zeros there. And that's what MATLAB does. It makes the smallest matrix it can and still accommodate your request. In other words, the smallest matrix it can that has an element 2, 2. And that's a 2 by 2 matrix. And what happens if the matrix exists, but the element we specify doesn't exist? Let's try to peek at a non-existent element. Let's look at the element of the 3 by 4 matrix that's on the 4th row and the 5th column. That doesn't exist. Well, we get our hands slapped and we deserve it. But an assignment to a non-existing position like this is another thing entirely. Let's assign a value to element 4, 5, say 456. So what's this? Well, MATLAB has had to extend the size of the matrix from 3 by 4 to 4 by 5 to accommodate our request to put something at element 4, 5, the 456. There it is. It's right there. We didn't tell it what else to put on the 4th row, and we didn't tell it what else to put on the 5th column, so it puts zeros there. There's one pitfall we need to point out concerning the first element on the 1st row. Let's set that first element on the 1st row to the value 99. It's 1 right now. We'll change it to 99 there. So we see our matrix with the 99 replacing the 1. That works fine. You might be tempted to do this because we've talked about how X as a scalar is the same as a 1 by 1 matrix, and it kind of looks like the same meaning here, but it's not. It's entirely different. What we have just done is obliterated our entire matrix and replaced it with just the 1 by 1 scalar matrix, 99. Well, we know how to access or change individual matrix elements, but you know we can change multiple elements at a time using the so-called subarray operations. Let's see how that works. Let's come up with a little simpler matrix this time. Just 2 rows. One of my favorite matrices because it's so easy to type. 1, 2, 3, 4, 5, 6. Let's look at a subarray. I'm going to type X, 2, comma, then 1, 3. What I've done here is said that I'm interested in just the 2nd row, and I'm interested in the 1st and the 3rd columns. I want to see that. So MATLAB slices off that 2nd row, and it gives me the 1st and the 3rd element on the row, and there they are, 4, 6. This is a subarray. This is the whole array, and this 4 and this 6 taken together is the subarray that we've specified. The comma is required, by the way, this one I'm talking about. Let's try doing without it. We get an error. And it's just as easy to specify multiple rows as multiple columns. So here we go. I'm going to say I want row 2 first and then row 1. And I just want to look at column 2. Now let's go back and look at what X is. It's still visible up here. We've asked for row 2 first, and there's the 5, and then row 1, and there's the 2. We asked for the 2nd column each case. So it puts the 5 first and then the 2. And here's a combination of multiple rows and multiple columns. For my rows, I'm going to say I want row 2 first, and then row 1, and then row 2. And then for the columns, I want to start with 3, and then go to 1, and then 1 again, and then 2. You can do anything you want to, as long as you're picking elements that are actually inside the array. So let's just look briefly here. We took row 2 first, And row 2 had a 4, a 5, and a 6 on it. And we asked for columns 3 and then 1 twice and then 2. So here the 6, the 4 is repeated because we asked for it twice, and then the 5, and then you can see what happened with the other rows. You can do any combination you want as long as the elements you request exist in X. Let me give an up arrow to repeat the previous command, and I'm going to change that 2 to an 8 and hit enter. Well, MATLAB didn't like that because we asked for elements that didn't exist inside X. And you can use the colon operator to form a subarray. As an illustration, let's do this without the colon operator. Spacing this out so you can see a little better. But we can do the same result with the colon operator. Let's do it that way. Instead of this 1, 2, 3 vector, which I wrote out explicitly, this time I'm going to get the same thing with the colon operator. This is not really a new concept. It's just a combination of two concepts that you've already learned. First, you learned that a vector like 1, 2, 3 can be used in a subarray operation. And second, you learned that the colon operator can produce a vector of evenly spaced numbers. In this case, 1, 2, 3. And you can get as fancy as you want with this. For example, let's do this. We'll put 2 colon minus 1 colon 1 for the rows we want, and for the columns, 3 colon minus 1 colon 1. We're going backwards on both of them. And there you have it. MATLAB provides a very helpful way for specifying the last index of a row or a column. Here's an example. As you might guess, the word end here means the last row index in the matrix X. And here's how you ask for the last column index. I'm sure you can guess. You just put end in the column position. End is an example of a keyword in MATLAB. The term keyword is a computer science term, and it's used for all programming languages. Its definition is simply a word that has a special meaning in the language. And every programming language has keywords. Here, the special meaning of this keyword is last index. A keyword is also typically reserved, meaning that you can't use it as the name of a variable or a function. Let's try to do that. We'll set end equal to 5. Oops. As you can see, MATLAB says it's a reserved word. The keyword end may not seem all that helpful to you right now, but we'll see later that it's very helpful when we write a program in which we can't know what the last index is. That actually happens a lot. And when it does, end will always give it to us. Here's some more examples of end. You can even do it in both positions. And here's 2 and 1 and 3. So we pick the second, the last, the first, and then the last element again on the third column. And you might be surprised to find that end can be used in arithmetic expressions. Subtraction's the most common. Let's do one of those. Let's remind ourselves what X is now. It's 1, 2, 3, 4, 5, 6. So here we go. 1 end minus 1. So this means we want to be on the first row. And instead of the last element, we want 1 before the last element. N minus 1 means end, which is the index 3, minus 1, which gives us the one before that, 2. And here's another one. And finally, if you want the last two elements of the first row. In reverse order, you get them. Addition is a little bit less common with AND, and it'll cause an error if you're using it to look beyond the end of a matrix, or trying to, like say this. But it's perfectly legal in an assignment operation, like say this. Notice that X has gotten bigger. Up here we see it was 1, 2, 3, 4, 5, 6, 2 rows, 3 columns. Now it's 1, 2, 3, 4, 5, 6, 17, 0, 0. When we put AND plus 1, we said we wanted to put 17 on the third row. Well, there wasn't a third row, so MATLAB added one. We told it what to put in the first column. We didn't tell it what to put in the other two columns. So as usual, it guesses that we want zeros there. AND can also be used with the colon operator. Here's some examples of that. Let's see what we've done here. We want row 1 here, and we want to start at column 1, jump by 2 until we get to the end. Well, row 1 has a 1, 2, and a 3. We jump over that 2 and we get a 3. 1, 3. Here we want the third row, and here's the third row, and we want to start at the end and go backwards to 2. 0, 0, and there's the 0, 0. And in this last one, we want row 1. Here's row 1. We want to start not at the end, but at one short of the end. That's here. And go to the end, 2, 3. And so you see that we have a 2, 3 here. Well, MATLAB also provides a shorthand for one particular phrase, 1:end. Let's start first of all by putting 1:end, 2, 2, 5, 0. We want to go from the first row to the last row, and we want to stick on column 2, and here it is. Let's look at this. Instead of 1:end, I just put colon and then the 2. And it's the same thing. The colon stands for 1:end. It's a shorthand. And of course, it's the same with the column indices. So we could do this. And that means we want row 1 and then all the elements on that row. 1, 2, 3. And of course, you can use it in both positions. We want all the rows and all the columns. But that's just the same as X. So this isn't a shorthand. It's more like a longhand. And of course, this is even longer. But all three of these things give us the same thing. But the point here is that MATLAB opts for consistency, which means it always lets you use these expressions for any index with no exceptions. This emphasis on consistency is a hallmark of a good programming language, and all the programming languages that are in heavy use today, including C, C++, and Java, and even good old Fortran, all emphasize it too. Well, so far we've used the array operations just to look at elements inside a matrix, but you can also use them to change the values of elements inside a matrix. Let's look at an example of that. I'm going to give the subarray 1 to end and 1. And if we look at that, we see that's elements 1, 4, and 17 there on the first column. If I give this operation, which is an assignment operation, we see that we have assigned minus 44 to every one of the elements in that subarray. In other words, the whole first column. And you'll notice that, as usual, we get to see the whole array when we do a subarray operation. Here's another one. Now what we've done is told MATLAB that we're interested in all the rows and we're interested in columns 2 and 3. And we want to set all those elements each to the value of 9. Arrays can be on the right side too. Let me show you what I'm talking about with an example. I'm going to type the same left side that I just typed. On the right side, I'm going to specify an array. There, you can see what's happened. The array that I specified on the right side just fits exactly into the subarray that I specified on the left side, and so MATLAB has dutifully put it there. And the size on the right side has to match that on the left side. It's a rule. Let's try to violate that rule and see what happens. Here on the left side, I'm putting exactly the same thing that I did before. But on the right side, I'm giving just a row vector, and that's not the same shape. And MATLAB complains.